Hello. Before we start the actual physics part of the class, I want to go over a few calculus things that are going to make life easier or are just completely fundamental to being able to do this class. So the first one is just going over some common derivatives. So the derivative of x to the n equals where n is some number, is equal to n times x to the n minus 1. So for example, ddx of x squared is equal to 2 times x. 2 times x to the first power, which is just 2 times x. Uh, the next one to bring up is that the derivative of the natural log of x is equal to 1 over x. So even though for most of these, you're going to, even though 1 over x is polynomial in the same way that x squared is, the way to get there from the derivative is to take the derivative of the natural log of x. The derivative of e to the x is equal to e to the x. This is kind of the definition of the uh, of Euler's number e, where anytime you have an exponential, say like 10 to the x or 2 to the x or something like that, then the derivative is going to be based on the size of it's going to be based on the size of uh, the function at that point. So the derivative is proportional to the size of the function, is what uh, is happening with any exponential. And then the definition of E is that it is exactly equal to the derivative. The derivatives is exactly equal to the derivative of each, or the value of each of the x. So this is a useful equation because if we have d dx of some function y of x is proportional to y of x, then we can know that it's going to be some sort of uh, exponential e to the something times x, because and we're going to get more into that in a second, what it means to have something times x. But because the definition of dx of y is proportional to y, is gives us the clue that d dx of is of e to the x is equal to e to the x. So y is some sort of uh, is equal to something times e to the constant times x, where the constants there to keep units tracking out and to keep us talking about units. So d dx sine of x is equal to cosine of x, and d dx cosine of x is equal to sine of x. But what this also means is that d squared dx squared of sine of x is equal to negative sine of x. So d dx squared of cosine of x is equal to negative cosine of x. So where you have a differential equation where the second derivative of some equation is proportional to the negative value of that initial function, then you know that y of x is equal to something times sine or cosine of some constant times x. So when we talk about units, I'll get more into the importance of these constants. But for now, this is just some common derivatives, and it also gives you an idea of what to look for when you're looking for different types of problems. So, or when you're looking at different types of differential equations, which are equations where the derivative is a function of the initial function that you're looking at. So this is like very good and common, but we're going to need to do something a little more than that. So in addition to that, I'm also going to go, oh, shoot. Sorry, share screen. I meant to clear the whiteboard rather than completely get rid of it. So sorry. In addition to that, I'm also going to go over a couple of more complicated calculus things that you should have known by now. So the first one is the chain rule, which is going to which tells you what happens when you have a function inside of another function. So for example, if I have the function f of g of x, then d dx of f is equal to d dg of f times the derivative of what's inside, so dg dx. So you take the derivative of the function with respect to what's inside, and then you take the derivative of what's inside with respect to x, or your initial equation that you're looking for. So for example, if we have cosine of omega t, then d dx, or d dt of this, and cosine is just a constant, or not, cosine is a constant, omega is just a constant that tells us the value of, or that keeps units from falling out. And again, I'll get into this when I get into units. But for now, we have it's sine of omega t, so negative sine of omega t, because that's the derivative. That is the derivative of d with respect to omega t. And then you derive what's inside. So that's times omega times 1, because that's the derivative of d of omega t, the function inside, dt. So this is going to be equal to negative omega sine omega t. It's really useful, and it's something that is going to end up being necessary, because everything that we work with in physics is going to have units. So units are something like time or length or mass or weight or force or something like that. But these equations have to include some function. These equations can't take out the cosine of 1 second or the cosine of 1 meter or anything like that, because that doesn't mean anything. So you have to have this constant out front that tells you, that converts from the units of whatever you're trying to take a derivative of to constants, to a constant number. So omega has units of 1 over time if t is time. So time times 1 over time is going to give you no units, which is just going to be a number, which is what we're looking for. So for a more complicated version of this, if we have e to the negative x squared over 2 sigma squared, where sigma is not a, or where sigma is just another one of these not equations, another one of these constants in order to keep the inside of the function with no units. So if we do that, and then this function is called a normal distribution, if we take the derivative of that, then it's going to be e to the negative x squared over 2 sigma squared times negative 1 over 2 sigma squared times 2 times x to the 1, because the derivative of an exponential is just itself. So this is dg, and then this is dg dx. So it's just itself times the derivative of what's inside. So this is going to give you equals negative 1 negative x over sigma squared e to the negative x squared over 2 sigma squared. So that's important. That's something that you definitely need to do, and I am going to test on. So if you can't do that, then reach out to me and I'll try to come up with a way to help you, or reach out to me, or reach out to the student services on campus, because this is absolutely something that you need to be able to do. So the next thing that we're going to do is called the product rule. Where if you take some function of x times some function of g, and you take the derivative of them, d dx of f times g, then that's going to be the derivative of f times the original g function plus f times the derivative of the g function. So if this is pretty simple, what might be a thing that we could do is just x times e to the negative kx, and then take the derivative of that. So that is going to be equal to 1 times e to the negative kx plus x times negative k times e to the negative kx, which is equal to 1 minus kx e to the negative kx. So in order to find dg dx, you need to use the chain rule as well, but this is also the product rule, so that's how you do it. And the last thing that I'm going to get through in this video is something that is basically just a special case of the product rule called the quotient rule, where instead of taking the derivative of f of x times g of x, you take the derivative of f of x divided by g of x. But this is kind of suspiciously easy, so you can do the product rule, or you can just use the product rule to do this, because this is equal to f of x times g of x to the negative 1. So this derivative is going to be equal to df dx g to the negative 1 plus f times the derivative of g to the negative 1 g to the negative 1 dx, which, going back to our chain rule, is equal to dx g to the negative 1 plus f of 1 over g squared, because that's the negative 1 over g squared, because that's the derivative of 1 over x, right? So negative 1 over g squared times the derivative of what's inside, dg dx, which is overall going to give you df dx times g minus f times dg dx over g squared. I'm pretty sure that's right. I don't I'm not qualified to teach a math class from first principles, because I have physics degrees, not math degrees. And I don't use this product quotient rule by itself. I just use the product rule because it's simpler to do. But this looks like a special form of the product rule, which is just for if there's two functions and one of the functions is on the bottom of the other function. So that is just a review of math that you really should know. So if you don't know it, then you need to catch up on it before you take the class, or go forward with the class. And then the rest of this is not going to the rest of the videos for my math introduction are not going to be things that you probably already know. They're just going to be tricks that physicists use to do to make life simpler. Okay. Thank you very much. I will see you in a second.